This video is on the objective perform and interpret a hypothesis test for the mean, right, a population mean, given that the population standard deviation is known, right? So sigma is known, meaning are, if you're doing critical values or test statistics, those will be z-scores, right? We'll be dealing with the standard normal distribution. And this is using technology, right, a calculator, and I'll be going over how to do this with a TI-84 Plus. If you have a TI-84, 83, be very, very similar. All right, and this is also the second video on this objective I'm working on for a question related to this objective in your Newton Alta homework. So hopefully you've watched the first one, and hopefully these help you out. Now, again, if you want to see how they're instructing you how to use the calculator, click on more instruction, look at their instruction, their videos, their examples. Hopefully those help you out. All right, so here, a soda company sells one of its soft drinks in 12-ounce cans. In order to ensure that every can has at least 12 ounces in it, the machines in the factory are set to fill each can with an average of 12.1 ounces of soda. Every week, a quality control technician tests 10 cans, right? Takes a sample of 10 cans to make sure that the average amount of soda in the cans is still 12.1 ounces. If the conclusion of the test is that the number of ounces of soda in the cans is different, not equal to 12.1 ounces, then the technician will declare that the process is out of control and the machine will be stopped and recalibrated. Now, from previous tests, the technician found that the standard deviation of the number of ounces of soda in the cans is approximately 0.01. So this is sigma, right? The population standard deviation, from previous tests. We're going to assume here that sigma is 0.01. The number of ounces of soda in the 10 cans that were tested in this week is given below. So we are given actual numbers of ounces in 10 cans of the sample that this technician took. Assume that the standard deviation from the technician's previous test is the population standard deviation. So like I said, we're going to let 0.01 be sigma. Use a calculator to test whether the filling process is out of control. All right, identify the p-value from the calculator output, round to 3 decimal places. All right, so I'm going to go to my calculator. Remember how to enter a list of data. We're going to enter this sample. So I go stat, edit, and then I'll just enter it down list 1. You could enter it down whatever list you want. I'll just use list 1 because it's empty here. So one can that he sampled had 12.15 ounces. And then another can had 12.04 ounces. And I'll be back when this is done. I'm going to pause it real quick. Fill them all. I'll start this up again when those are all entered. All right, so I've entered those 10 cans worth of ounces, that number of ounces in those 10 cans. I have entered those down list 1. Now, on a piece of paper, they didn't give us any hypotheses here. I'm going to write down what the hypotheses are and what we're testing. So let's pull that up here. Move the calculator out of the way for a second, because they didn't give us any of that. So the claim here, right? What's being tested? Right? What's being tested is that the average is different than 12.1. Right? That's what they got. They said if the conclusion of the test is that the number of ounces of soda in the cans is different from 12.1, then the technician will declare that the process is out of control. So this is what's being tested here. Is the average amount of soda in these cans different from 12.1 ounces? All right, then the null hypothesis and alternative hypothesis would be the following. Now remember, the null hypothesis is you assume equals, right? that the mean, the average, we're going to assume, we're going to assume that the average amount of soda in the cans is 12.1 ounces, and then test, the alternative hypothesis is the opposite of that, that they're not, that's not equal to 12.1. Now the significance level, right, alpha, was not given. Now they might give it to us after this, so I'm not going to say it's 5% or anything like that. But if it's not given, usually we'll assume that the significance level is 5%. That's a pretty reasonable significance level for most hypothesis tests. So I'll bring these back. Let's bring the calculator back now. And I've got that list of data entered, and now we're going to go to the test, right? So I hit stat, over to test. Now we're doing a test about a population mean here, about mu. And for a one population mean test, where the sigma is known, right, where the population standard deviation is known, that's the number one. That's this z test. Right? And remember, when you have sigma known, you're using z scores, so z test makes sense. Okay. So I enter on that. Now they're going to ask, do you have a list of data? Which we do. Right? I have a list of data entered, a sample entered. Or do you just have statistics? Right? Go to the second one here. If you're just given the sample mean and the sample size, go to stats. But we weren't given that. We were given the data. So I'll go to the data area. Now this first part, the mu0, that is what's the assumed population mean from the null hypothesis. And I said that was 12.1, right? We're assuming from the null hypothesis that the average amount of soda in these cans is equal to 12.1 ounces. So I'm going to enter 12.1 there. What is sigma? The next line. And we are told that sigma is 0.01, right? That was from this here, the standard deviation. The number of ounces of soda in the cans is approximately 0.01 back in the reading. So 0.01, not 0.01. All right. Then the list line is this. Where is your sample coming from? What list of data do you have your sample entered in? And that's list 1. I already have that. Now if it's in list 2 or list 3, just hit second and go 2 or 3 or 4 or 5 or 6. To get different lists in there. But it's already list 1. Then the frequency list. There is no frequency list here or a probability list. There's just, they're all being counted one time. Each of these cans was counted one time. So I'll just leave that as 1. And then what are we testing? Are we testing that the mean is not 12.1, less than 12.1, greater than 12.1? Well, this is another two-tailed test. Is it a two-tailed test, a left-tailed test, or a right-tailed test? It's a two-tailed test. We're testing to see if the average is different than 12.1 ounces. So I'll leave it flashing there and then calculate. And then you see it gives me the sample mean x bar at the bottom here, 12.103. Right, so the average ounces in this sample of 10 cans was 12.103 ounces. Gives you the sample standard deviation, the sample size, but those aren't the important things. The most important stat here, the most important value given is this p-value. Now above that is z. That's the test statistic. That's the z-score for this sample mean, 0.9. This is how many standard deviations above 12.1 was this 12.103. There's only 0.948 standard deviations above. But the most important value, the one we're going to use to make our decisions, do we reject the null hypothesis or not reject it, is this p-value. Now the p-value is given as 0.3427, which to 3 decimal places would round to 0.343. So back in the assignment, for p-value, I'm going to enter 0.343. So that's correct. Right? It's just a simple matter of entering data. And that's it. Wow. Okay. There was another question you saw in the first video on this objective. There were some questions that had further parts to it, and then they asked you about the conclusion. Let me tell you what the conclusion would be. All right, let me pull up my paper again, and got the calculator. So remember, if the significance level is not mentioned, we're going to assume it's 5%. Now they tell us here from the calculator output the p-value is 0.343. And when you're doing this p-value method, you compare the p-value to the significance level. Well, the p-value is clearly greater than alpha. Remember, when that's the case, you are not rejecting, you don't reject or fail to reject the null hypothesis. So that means we're keeping this and not supporting this. We're not rejecting the null. So based on this evidence, you say, looks like the average amount in the soda cans is 12.1. That's reasonable to assume at the 5, if I was using the 5% significance level. I mean, this would also work for 1% significance or whatever, but really up to 34.3%. But we'd keep this. We'd keep the null. We'd reject the alternative or not support the alternative. So basically we're saying that there's not enough evidence. There's not enough evidence or not sufficient evidence to support the claim that the mean amount of soda in the cans is not 12.1 ounces. And then if that was the case, if we're not saying this, we're not saying that the mean is different than 12.1, then it's not unstable, right? We'll say the process is not unstable. And we wouldn't go in and fix anything, right? They said in the problem, if it was unstable, then they'd go and recalibrate the machines. I'd say based on this particular sample, I wouldn't have to go back and recalibrate the machines, right? So if they ask you anything about that, they should. You saw in my first video on this objective, they may ask about what kind of conclusion would be made then. Would you reject the null? Would you not reject the null? And then based on that, would you support the claim or not? Is there enough evidence to support the claim or not enough evidence to support the claim? So just be aware that you might be asked that kind of stuff too. Alright, so hopefully these couple videos help you out when you're working on that objective with the calculator. And yeah, thank you very much for watching.